Simulators. When I design a circuit, I may come across many difficulties and adventures. It might be easier to build simple electronic circuits physically, but once I start to build complex circuits, it will be difficult to predict the output of the circuit. That's where simulators comes in. Before building a circuit physically, we first design it in a simulator, in which we can give inputs and know the outputs. The simulator which we are going to use is LTSpice. Using LTSpice, we can place various components. We can wire the circuit. We can give an input and get an output. And there are various possible simulations. And I will show you DC simulation. These are some important shortcuts which I can use in LTSpice. I open LTSpice. So first we need to open a new schematic. This is a new schematic. Let's build a simple circuit with LEDs. This is a simple circuit which I have a source of 9-volt battery, and I connected it across a resistance which is 470 ohms, and I connect 3 LEDs in series. This is the reference without which I cannot measure any input or outputs. So I take ground as a reference. I have a menu bar here. I can choose components from this title. Then if I want to cut something, I can choose this. If I want to paste, and if I want to find the reference, and if I want to find the wire, and these are all various components like resistor, capacitor and inductor. So if you want to even rotate any component, you can use this one. So these are all rotate. I need a voltage source, so I can either choose it from the components here, or I could just press F2 to get the components. Here I type in voltage, so here you can get the component, and once I get it, I place it here. And if you notice that the size is too large, you can zoom in or zoom out, whatever you want. For that you can use control and scroll button to just zoom in or zoom out, or you could choose this icon to just zoom out. Then I need a resistor. I could choose the resistor from here, or I could press even R to get the resistor, and I need to rotate the resistor. For that I use control R to just flip it, or if you choose to take this rotate icon, you can choose it. So I place it here. Placing the resistor, I can give the resistance value. Just right click on the component, and here I want 470 ohms. Here I need 9 volt. Then I need 3 LEDs, so I go inside and type in LED, give OK. So I place it here. So before choosing an LED, we should specify the model number. For that I need to click on this. I just right click and I pick a new diode. Here when I'm choosing an LED, I choose the most commonly used one, which is this one, Initia. So actually if you select this, and if you see that the average forward current it uses is actually 30 milliamps, and the breakdown voltage is 5. I need 3 LEDs, so I can just copy this LED and just place it. For that I can press F6, and this icon shows that I can copy any component. So I click on this and I copy. I need one more, so I again click and copy. Then I need to wire the circuit. I can use F3 to wire. So when I press F3, it wires, the wire comes up. Then I click on the square one, so it connects to the components. So this is how I connect. I wire the circuit. Then I need a ground reference. Then I press G and get a ground reference, and again connect this to here. I'm picking up 3 node points. For that I draw a node point and I label it, and I just say this is node number 1. So I want to run the simulator, and this is the icon which I can run the simulator. So this window pops up and I choose DC sweep, where I can give a starting voltage and a stop voltage. I do a DC sweep because the battery which we are using in practical applications can decay very fast. So it asks for name of first source to sweep, which I give V1. Then the starting voltage I give it as 0. So the stop voltage I give let's say 12 volt. Then the increment, which is the slope, I want to increment the slope by 0.1. So when I give the values, the simulator runs. And if you want a vertical window, you can also choose. I want to see the input, and when I go near the input, it shows a probe structure, and when I click on it, it shows that the voltage is being swept from 0 to 12 volt. And I want to see the voltage at node 1. So here you could hardly see the waveform. If you want to change the color, you can right click on this and you can change the color. So now you could actually see. Interestingly, the voltage is being tracked till, let's say, 7 volt, and after that the output voltage actually changes. This shows that after 7 volt the current is actually being generated. Then I want to measure the voltage at node 2. When I press on this, you could actually see that the voltage here it is less, and at node 3 the voltage is almost 2.5. so each LED it uses around 2.5 volt. If you want to measure the exact voltages, you could just, and this you could move. And if I want to set my input voltage at 8, then it actually shows that the voltage that the diode takes is around 2.5. so each diode takes around 2.5 volt. If I want to measure the voltage across the resistor, I need a reference. So I right click on this and I mark the reference, and I click on this, you could actually see the voltage. So I'm setting the input voltage to 8, then the remaining voltage I get is around 292 millivolt. If you want to measure the current, then you actually click on the components. So you could see that when you increase the voltage, the current increases. Here the direction of the current is negative, and when I hover over the voltage source, then the direction of the current is shown by the red arrow mark. If I want to measure the current at diode D1, and this is the output waveform you get. So you could see that here after maybe 6 volt the current actually gets generated. So the LED
it starts to glow after maybe a little after 6 volt. If I measure the current at diode D2, it's the same, and at diode D3 it's the same. Now you will be able to clearly see the waveform. Each node changes and the current in each diode remains the same.